Hello, here in this video we're going to check out 3.4 Part 2, Zero Product Property. So far we've been learning how to factor quadratic expressions in ax squared plus bx plus c form. We're going to take that knowledge and apply it to quadratic equations so that we can find our solutions. And remember that there's other ways that we can hear that term solutions as well. Another way is x-intercept. Another way is zeros. And the final way is roots, where all of those words mean the same thing. So x-intercepts always have coordinate points like this, to where there's some number for our x-coordinate, and the y-coordinate is 0, right? And this is one reason why they're called zeros, because the y-coordinate is 0. And remember that visually, x-intercepts or roots or solutions, any of the ways that they might choose to express it to you are, if I was to draw a quadratic, would be the two spots where we cross over the x-axis. So, to find our x-intercepts, we need to make sure that our equations are equal to 0. That's why it's called the zero product property. So, more on this is that when we multiply two terms together, if one of them is 0, the answer will always be 0. Right? And think about that. If I'm multiplying two things together, and one of them is 0, no matter what we put right here, the answer will always be equal to 0. So, once we factor our equation, we are going to set each term equal to 0 so that we can figure out what the different solutions would be. And here are some examples that I've already factored for you. It says use the zero product property to solve for your x-intercepts. So what's going on here is that this original equation would have been x squared plus 2x minus 15 is equal to 0. I've already factored it for you to x minus 3, x plus 5. To solve for this now, what we're going to do is use the zero product property, to where if I can figure out what makes this piece equal to 0, when it multiplies by the x plus 5, everything is equal to 0. If I can figure out what makes this piece 0, anything multiplied by 0 is equal to 0. So when we get onto situations like this, all you have to do is, once you factor it, is you set up each piece equal to 0 and solve. So this one ends up being x is equal to 3. This one ends up being x is equal to -5. And those would be the two spots that we cross over the x-axis. If you wanted to check this, you could go back to the original equation and substitute in either one of these. I'll choose the 3. 3 squared is 9. 2 times 3 is 6. 9 plus 6 is 15. 15 minus 15 gives us our 0. So it checks out. And you would get the same type of phenomenon to occur if you checked it with -5. So what factoring does is it allows us to find those two numbers that would make this equal to 0 very easily. If I just showed you x squared plus 2x minus 15, it might take you a little bit of time to figure out what numbers make that equal to 0. However, once you factor it, you can determine very quickly what those numbers are, because you take your factors and you set them up equal to 0. So this one here, it's already been factored for us. We would take our two different pieces, and you don't have to include the parentheses, because the parentheses won't do anything at this point, but so I'll rewrite it without them. You go through and solve it for your variables. So in this case, I would add 2 to both sides to get that one of them is t is equal to 2. This other one, I would add 1 to both sides. And then I would need to divide both sides by the 4 to get that my other x-intercept is 1/4. So here's what's also helpful about the zero product property. It can help us find x-intercepts even when they are fractions. Previously, when we had been doing this with tables, we really only included whole numbers in our tables, and so if the x-intercept was at a fraction, we weren't really able to locate it. But now with factoring, we can locate fraction x-intercepts no problem. So here you'll see other examples of using the zero product property. And one more time, all you do on it is you take both pieces and you set them up equal to 0 and you solve. So what I'm going to do here is I'm going to pause the video and I want you to go through and use the zero product property on the rest of these. And then after you've completed that, press play and then check out the answers to make sure that you are using your zero product property correct. I'm now going to write in the answers. Alright, and here are the remaining solutions for those other zero product properties. Now, another thing that we will be able to do is that we'll be able to write a quadratic equation with given roots. And it's very simple. If I told you that a quadratic equation had roots at x is equal to 3 and x is equal to -2, all you would do to write this back into a quadratic equation is work backwards through what we just did to set this up into a scenario where we have pieces equal to 0. So what I could do here is subtract 3 from both sides to get that x minus 3 is equal to 0. This one I would add 2 to both sides, and I'd have that x plus 2 is equal to 0. And then with both of those being equal to 0, that would tell us that our quadratic equation would be those two factors. And you could FOIL those out to get x squared plus 2x minus 3x minus 6. And there would be your quadratic equation, x squared minus x minus 6, that has those two roots. So what this is allowing us to work backwards and forwards through this process of where if we're given an expression, we can solve for its x-intercepts. If we're given x-intercepts, we can backtrack them into factors and multiply back out to find the quadratic equation. You can even do this with fractions, to where if I gave us that x is equal to 1/2 and x is equal to 2/3, what we'd want to do is a similar concept, except as you may have noticed, up here, none of the factors ever have fractions in them. So like this one here, if I write the workout for this one, when I solve 7n minus 2 is equal to 0, we add 2 to both sides and then divide by 7. So when we're working backwards through this process, we'll do a very similar thing. The first thing that we'll want to do on situations where you have fractions is you'll want to multiply both sides by the denominator to help clear the fraction. So here we'd have 2x is equal to 1. Those 2's cancel out. Here we'd have 3x is equal to 2. And then you go through and do your subtraction. So this one would land at 2x minus 1 is equal to 0. And this one would land at 3x minus 2 is equal to 0. And you could then multiply these back out with FOIL here to get us 6x squared minus 4x negative 3x and a positive 2. So right here we have just written a quadratic equation, 6x squared minus 7x plus 2. And that quadratic equation has the solutions of x is equal to 1/2 and x is equal to 2/3.